Okay, so our next presentation will be by Brew City Builders with an industrial warehouse design and construction. So Brew City, when you're ready, please commence.
All right, hello everybody. We are Brew City Builders and our project was industrial warehouse design and construction. A little bit about our project before we start. It's an industrial warehouse development and we're building it to suit, and the contract type is a cost plus fee. We have 3 mentors, all from Arco Design Build, and they are Jake Stefan, Brady Panis, and Tim Hefferon. And our team includes myself, Jason, Kevin, Peter, and Paul. So the warehouse will be home to ATD, a tire distributor. And this project is important because it facilitates the distribution of tires, which is essential for every transportation needs. And a good example of this right now is during this pandemic, a lot of companies need to ship out N95 masks and ventilators. And this will also provide jobs to residents in Peach County, Georgia, where this project is located. All right, like I said earlier, I'm Jason Copy. I'm a lead GA, and I am one of the construction managers on the project. Some of my past work has been a co-op with the Walsh Group in their building division, and the most recent project I was on was Wolf Point East, a high-rise residential.
My name is Kevin Kukla. I'm the structural engineer on the project. I have experience co-oping with Morgan Harbor, and while I was working there, we were working on a distribution center in Franklin Park.
My name is Peter Wynn. I'm a lead GA and I'm serving as one of the other construction managers on the project. I served as a field engineer co-op with the Opus Group on a multifamily residential project.
My name is Paul Rosemark and I've done undergraduate research for the university here.
In terms of owner needs and requirements, the request for proposal given to us stated that the facility is to be 80,600 square feet. Once again, that's a tire distribution facility with provisions for a 25,000 square foot expansion and also provisions for a 4,500 square foot office space. In terms of operational specifics, the client requested 8 dock doors with provisions for as many more as we could fit, 1 drive-in door at grade. For electrical service, they were requesting 480 volt, 3-phase 4-wire service at 800 amps, requesting a 50 by 60 foot bay size with a 28 foot clear height from top of slab to the joist.
So for structural engineering, the scope included the design for the steel structure and then the foundation design for the columns and the walls, then also the cast-in-place wall design.
For civil, I was in charge of the earthwork, cut and fill data, as well as considerations for pavement and transportation, and working with LEED and Envision standards to make our project as green as possible.
For construction management on this project, Peter and I took care of estimating, construction scheduling, the site plan, and the mechanical, electrical, plumbing, and fire protection equipment sizing and selection.
In terms of background info and then the codes we consulted, we were provided a complete request for proposal by Arco Design Build in addition to a geotechnical report with borings and stratifications. In terms of the codes consulted for this, we were working with the Georgia State Minimum Building Codes, ASCE 7 for structural design, the City of Byron's municipal zoning codes, ASHRAE 90.1 for HVAC, and a NFPA 13 for fire protection cost assessment, and then NFPA 70, which is the National Electrical Code.
So when we're looking at the existing conditions of the site, the highest point is 493 feet and the lowest point is 488 feet, so about a 5-foot difference. If we looked at the 3D model on the left, you can see that the southeast corner is the lowest point, and then same thing on the 2D map on the right side, so about a 5-foot difference. The 3D model is exaggerated to show the different grade lines. And then, so when we chose our alternate designs, the things that we chose to consider were truck maneuverability, cost of everything included, impact on adjacent properties since there is a elementary school on the left side, and then also the look of the property.
So we came up with 4 alternative designs. It's important to know that these designs were made early on before any of the kind of grading information was known. And also note that the existing road on the north side of this map does not have access to the site. So this is design 1, which totaled 13 total points. We decided to eliminate this design because of the high amounts of pavement and the upfront cost of building on the west end of the property. The advantages to this were the separated car parking lots and the truck traffic, and also the future expansion zone was more accessible if they wanted to do that later on. Design alternate 2 ended up being our chosen design, totaling 17 points. You will see a few changes were made to this design, and you'll see that in some slides later, such as the trailer parking moved to the south end of the lot and the pond size moved to the southwest corner. The advantages to this were it was the smallest amount of paving, and it was very aesthetically pleasing and very accessible. Design alternate 3 ended up being our second highest in points, totaling 15. Once again, the upfront cost of building on the west side provided much more upfront cost, and there's a lot more pavement for this one based on the parking lot location, and the pond was kind of in an awkward spot. Design alternate 4 was made to make truck traffic much easier, kind of in a linear fashion, and the parking lot was separated enough, but this design was eliminated right when we got the grading numbers.
Yeah, so as Jason said, design alternate 2 was selected for further revisions, and this is the final iteration of that, with the entire property being flipped on the east-west axis. So now that the truck court is on the south end of the property. In addition to that, a truck turning circle was added to the west end of that court to allow truck drivers to back in using their driver's side mirrors, and making operations generally easier for them. In addition to the south, you can see provisions for 22 trailer spots at 9 foot on center, and spaces for 54 cars to the east of the property, with miscellaneous landscaping as well.
All right, so the design for the structural scope, we started with getting the load calculations, which include the dead load, snow load, roof live load, and the wind load. And then once that was determined, we picked the steel deck. And then after that came the open web joists and girders. And then we sized the structural steel columns. After that, we did the wall design, which was cast in place walls 39 feet high. And then the footing design for the walls and columns, and then the slab on grade, and then the construction drawings. So here's just some examples of the connection details that are provided in the drawings. You can see the joist and girder connections. And then here's some joist and wall connections. And here's a typical loading dock section. You can see the sizes for the openings. And then here's a typical column footing detail. And this is just showing so I used a program called Structure Point to calculate the reinforcement in the walls. And so this is showing the reinforcement that's required at the different sections. And again, here's a view of the structure. You can see the base sizes. You can see the different columns and joists and girders. And then here's a view of the south elevation. You can see the dock openings and then the 2 drive-in doors.
So moving on to the civil data, just reinforcing the parking information. We have room for 54 parking spots, 3 ADA compliant. This is a tire distribution center, so we have trailer parking for 22 trailers for 18-wheelers. And then again, the truck turning circle, that was a point brought up by our mentors. So the truck turning circle is used so drivers can use their driver's side mirror. It's a convenience for them. And then moving on to the earthwork information. For pavement, since our two entrances are separated for standard cars and trucking, the trucking pavement will be as shown there. And then light pavement is less to save on money, and also the standards, you don't need as thick a pavement for just standard cars. The building pad is 6-inch stone, 6-inch concrete. And then also on the site, we will be stripping 4 inches of topsoil as discussed in the geotech report that we received. So using the software called Earthworks, I was able to calculate all the amounts for each thing. So it shows the amounts for concrete, stone used, crushed stone, binder, and wearing for the pavement. And then for cut and fill, it shows the data. And then also for topsoil export. So for cut and fill, we wanted the soil to be going at a 2% slope away from the building for stormwater management. So that's the data for the cut and fill according to the 2% slope. And then also part of our project we wanted to focus on was green, and envision was something that we learned in our lecture period. So these are areas of envision that we could have focused on for our group. So minimize noise, we included ceiling banners or hanging baffles. So for ease of traffic, we put in separate entry and exit points for standard cars and trucking. And then enhance views, since there's a school on the other side, we wanted to increase landscaping. And then economy, we're including more jobs to the local economy. And then trying to follow natural grade lines, increase stormwater management capabilities of the retention pond. Moving on to LEED, we went on the LEED website and got the checklist for warehouse and distribution centers, and we took more of a holistic approach. There's a Excel doc on the websites for different categories, and with our project, we believe we could qualify for LEED certified if this was a real world site.
Moving on now to construction estimating. This is just going to be a little recap of our top items that cost the majority amount of money on the project. This includes earthwork, which involves clearing, stripping, cut and fill, finish grade, compaction, and export of all the earthwork that needs to be done before any building goes up. And then concrete was another big one. We had the slab on grade, the rebar that goes into every part of the concrete, the tilt-up wall panels, which we used for the structure, formwork, and then curb and gutter for both the truck traffic lots and the car parking lots. Design fees ended up being our third largest, which includes the architecture fee, the electrical consultant fee, HVAC and plumbing fee, and structural consulting fee. Paving was our fourth highest, and you can see the quantities of asphalt and concrete we have on this project are pretty significant, so that ended up costing a lot. And then structural steel was our fifth highest, which includes the joists, girders, columns, and erection of the steel, and of course the roof deck. And these top 5 items comprise of about 75% of the total project cost. And you can see that on the following slide in our chart we have. So those first 5 I talked about on the previous slide are from the blue all the way to the light blue, including that orange, gray, and yellow. And then you can see about 25% is all these other estimates that we had.
Yeah, so the remaining cost of the 26% is included in interior fit out, dock equipment, gypsum walls, as well as miscellaneous equipment such as steel bollards and landscaping. So moving on to the actual breakdown of the cost, the total facility as well as all the site work to be completed ended up costing about $4.7 million, or about $58 a square foot. In terms of the breakdown of direct and indirect costs, we're looking at about 44% for material costs, 25% for labor, 21% for equipment, 10% for general conditions and fees. And on top of those direct costs, we assigned a 3% contingency based on RS means value for final working drawing stage. And then on top of that, we assigned a 10% overhead and profit given RS means data for bids that include subcontractor overhead and profit. Moving on to the electrical power plan. This is one of the more difficult elements to meet owner requirements. So the owner requested 480 volt service at 800 amps. The utility provider is providing that at 15,000 volts. And so that service is being fed into the main electrical room, which is the green room you see to the east end of the property. And from there, it's distributed to 4 different service zones, each serviced by their own step-down transformer to service dock equipment, lighting, or convenience outlets in the office spaces or other site lighting equipment. For HVAC, the specifications call for 3 air changes per hour, and those calculations were performed in accordance with ASHRAE 90.1 standards. We had to find out how many British thermal units or BTUs we were losing through the walls and insulation, and from there we had to make it up with heaters and exhaust fans. In the end, we ended up sizing 15 exhaust fans, providing 4.9 million cubic feet an hour of air movement. And we also sized 4 Cambridge SA250 units, providing 10 million BTUs of heating capability when we're losing 9.5 million. In terms of the schedule and durations on your screen right now, you can see the critical activities for this project. So right now we're targeting a 44-week duration, 220 days. This is assuming a 5-day work week. And if we were to start on Monday, May 5th, May 4th, this project would be completed on March the 8th of 2021.
Some of the challenges that we overcame for the structural aspect, for me, it was learning new computer programs. Since I had to design the load-bearing walls, I had to learn new programs to get the reinforcement for that. And then also included in that is designing new structures such as the walls and foundations.
On the civil side of things, so again, as said this before, with structural, learning a new computer program called Earthworks, and then also with the new proposed grade lines, I kind of had to play around with it that would make the least amount of soil export and the least amount of change to the natural grades that would save us money. And also just following Georgia's specific code, since none of us are from Georgia, just looking up new information.
On the construction management side of things, one of the challenges was sizing the equipment so that you're not operating at a dangerous level, so over 95% capacity or something like that. So finding a compromise between cost and operations and maintenance costs. Second challenge being balancing the coverage of scope as well as the time required for design of certain systems such as plumbing and fire protection. And the third challenge being getting an accurate estimate given data from 2011 as well as relative inexperience with assigning these costs and distribution of percentages.
Overall challenges for the group, modification to the scope based on the semester timeline. We implemented an internal schedule for deadlines early on, and as new information was coming in, we had to adjust some of those numbers and adapt accordingly to meet our deadlines. Another one was justification of site design selection. As I said earlier, we made those alternate designs pretty early on, and as new information was coming in, we'd select different alternatives, which is how we ended up with our final one. And then, of course, transitioning to remote learning and no in-person meetings was a little bit of a challenge for us, as well as other groups. That concludes the presentation. We'll take this time to answer any remaining questions anyone might have.
Okay, thank you very much. As is tradition, we'll take questions from the mentors first. So Brady or Jake, any questions?
Want to start?
Can we go back to some of the structural details? Those went pretty quick. I'd like to look at those.
Anyone in particular?
Okay. Is this where they started? We didn't get a chance to look at the footing or the column all that closely.
Here's the column footing.
Okay.
Not too terrible.
Not bad. Well, that didn't really generate any questions. You want to run through yours first?
Yeah, I got a couple for you guys. Can you hear me okay?
Yeah.
We can hear you.
Socially distancing away from the microphone. So, the site selection process, if I remember for you guys, we went through a lot of different stuff, right? A lot of different things, a lot of different things that kind of caused you to change direction a little bit at the beginning.
Yeah.
So would you guys approach that process a little bit differently if you had it to do again now at this point in time with either things that you learned or things that you considered?
Yeah, I guess from my standpoint, I had made those kind of sketches in Revit or in Bluebeam. I made those a little early on, so I think we could have saved time by eliminating, design number 4 because that had the pond on the north end. I probably should have waited for those gradings to come in and then just eliminate that one right off the bat. And, other details would come in slowly. So, maybe those 3 would have been good enough for that early on in the process. But
I mean, just to piggyback what Jason said, I think we should have paid more attention to the topographic data. We didn't really necessarily understand how the finish grades impacted stormwater management or draining water away from the building, or just generally how the different parts of the warehouse, connect to each other. For example, I wasn't aware that the dock was completely flat, or the truck court, mind you, and then it sloped away. I thought it was purposefully angled downwards like that, which impacted a lot of the design.
yeah, and one more thing, I was kind of concerned about separating the trucks and the car parking lots. So a lot of that consideration came in later when I was looking at pavement numbers. And if you have so much more pavement, it's going to cost a lot more money. So our final design ended up being the one that had the minimal amount of pavement. So maybe I could have done more designs kind of revolving around that aspect.
Yeah, I think you guys hit on it. There were definitely some things that, as you understood more, made a lot more sense. The pavement and the stormwater was definitely a big one that I was thinking of that really changed a lot of what you guys were thinking in terms of how the building was going to get laid out and where it was going to go. And flat sites, albeit easy to kind of work with from layout standpoints, make stormwater really complicated. And in some ways, it's a challenge on a flat site that you wouldn't otherwise have because you don't know where the water is really going and you don't know how to get it off. So that was interesting. Do you want to walk through the concept you guys had on stormwater a little bit? How you were handling it and where it was going and coming from and how it was getting there?
Yeah, Kevin, do you want to back to the site plan? So with the initial design alternative number 2, this entire property, if you can imagine, just flipped over the axis so that the truck court was to the north. And with that, relatively flat truck court to the north, we noticed that if we slope the entire site to the southeast, which is how it naturally grades, we're drawing water into the building, increasing, O&M costs as well as possible water infiltration. So the decision was made to flip the entire property so that everything naturally drains to the southeast. And if you can see in the southwest and south, we have some topographic lines drawn out just super rough. These are to represent a retention pond and a retention strip that will naturally capture any water that runs off the impermeable surfaces and then funnel it towards a storm sewer, which ties into the east end. If you can see the tiny blue line at the southeast. And so that was the kind of logic behind our stormwater management.
You got another question, Brady? You want me to hit another one?
Keep going. Mine's on schedule, so
I've got one, Jake, if you don't mind.
Yeah, go for it, Tim.
Guys, I know, and I was a little late calling in, so I apologize if I missed this and it's redundant, but I know early on in the site design, we had some pretty crazy haul-off numbers and costs attributed to haul-off of soils from the site. I know you guys were going to try and rework that. Where did that end up, and how did you guys kind of go through the process of trying to limit as much soil leaving the site as possible?
So right now in our estimate, we are including that 13,000 yards or whatever it was of soil. So that is included in the budget right now. But the thought is that an alternate could be added to berm onto the west side of the property. If you can see on the drawing to the west, it is owned by the Peach County Board of Education. So our thought process was to berm some of that soil on the west end, so that it would provide some sort of visual barrier between the school and the warehouse itself, because a warehouse isn't the most necessarily beautiful thing to see from an elementary school. So yeah.
10-4, and that'd be a great way to handle that excess soil on site. One more I have for you guys. I see that there's a truck turnaround on site. I guess one question would be, why is that necessary, and what is the thought process on putting that in?
Paul, you want to take that?
Yeah, so it was sort of so the drivers could use their driver's side mirrors. It was brought up in one of our meetings. Even though the pavement costs would increase, I think it'd be worth it to help out the blue collar guys as much as we can, just a mindful consideration for them.
Gotcha. Yeah, that's a great answer. Awesome. That's all I got for now, guys. Great presentation.
Quick question on your storm swale there. You've got the one swale running below your truck parking.
Yeah.
Is that sitting? What's the dash line above that swale that you've got your pond crossing?
Oh, that was just naturally on the topographic drawing. I think that's just property boundaries.
So it looks like you've got your storm ponds and your swale outside of the property line.
No, so this entire property was scaled out early in the process. We looked up Peach County GIS maps and we sized out. So the property is 500 feet from that northern fence line all the way down to the southern fence line that you see, and then 610 feet east-west. So the red chain link boundary that you see here are to scale what is included in that site.
Okay, so I think there's something wrong someplace on the scale a little bit, because when we built this building, it was really, really tight. And I do actually think that property line is probably correct in terms of the location it is, and there was probably something wrong on the GIS document, which you don't know this, but you'll find out as life goes on that that's often the case, that the GIS documents are often wrong. And so my guess is that it wasn't scaled correctly when it was either input, or you just had information that was there wrong from the GIS, because that happens a lot. But as an FYI, in reality, you probably wouldn't be able to do that trailer parking because you'd need to pull that pond up into your property, which is probably that line.
All right, that makes sense, yeah.
Life lesson, don't ever trust GIS. It's great reference. It's a trust but verify thing for sure.
Gotcha, appreciate it.
Okay, we have time for one more question. Any questions from the faculty? I see a hand up. Please ask your question. Jaime?
Yes, I just have a quick question. Probably I missed it, but why did you guys decided to use two types of payments instead of one?
So one of them is for the passenger cars on the northern side of the lot, and on the southern side is for the semi trucks. So with durability, we want to make sure that the pavement for the 18-wheelers would stand as long as it can.
And as a follow-up, how do you factor in the fact that you have to have like two very different set of equipment to build each of these two portions of pavement instead of just bringing one and paving the whole thing?
That is definitely a very good point. I'm sure that would add to the estimate of the project. We didn't really think of bringing in two different crews, I guess. That's something I would look more into.
Okay, great, thank you.
Okay, thank you very much, Brew City Builders. Good job. Our next presentation will be by Team LCMT. So we'll give them a few minutes to queue up their PowerPoint presentation.
All right, thanks everyone.
Good job,
Thank
guys.
you.
See ya.
Good job, guys.